Hey class, I hope you guys are doing well. Today we're going to go ahead and start reviewing over the unit of exponential and logarithmic graphs and functions. So first of all, let's review the different types of functions that we've been studying. So this first type of function is linear. Notice the exponent is to the first power. This is a linear function. Okay, it has a negative slope, so the graph would look like that. Okay, this second function here, what do you think it is? If you said exponential, you're right on. It's exponential. Notice the x is in the exponent. Okay, and then the second thing is we're going to look at the base here. The base is greater than 1, so we have a growth. So this is an exponential function, and it's a growth, so it's going to be increasing from left to right. Okay, let's take a look at this third function. Well, notice there is no exponent. This is actually called a constant function because that's all we have here is a constant with no variable. And constant functions are going to be horizontal lines, like horizontal asymptotes, similar. Okay, let's take a look at the next one. Notice the x is in the exponent, so again, we have an exponential function. And our base is less than 1, but greater than 0, so we're going to have a decay. So it's going to be decreasing from left to right. And then finally, our next function is, that's right, logarithmic. And it's translated 3 units to the right. So if we were looking at an axis here, we'd have to go 3 units to the right. And so it's going to look something like this with our vertical asymptote at x equals 3. Okay, so a little review on that. So let's go ahead and review solving. So this first one, we have not an exponential. This is a cubic function, okay? And so to solve this, since we only have one variable here, we can go ahead and undo GEMDOS. So we're going to undo the adding. Okay, so I fixed that problem. I noticed that I had the wrong constant here. It's supposed to be 20. So subtracting 20 on both sides. Okay, undoing multiplication next. And then finally, undoing cubic, which would be raising it to the reciprocal power on each side. We get x equals, and the cube root of 8 is 2. All right, moving on to number 2. Again, so this is exponential. Notice the x is in the exponent. And to solve this, we're going to undo GEMDOS. So we're going to undo the adding and subtracting first. And 18. Then we want to undo multiplication with division. And now you have a couple options here to solve this. We could log both sides, do the power property, but I think it's going to be easier just to make the bases the same. So if I want to make 9 into base 3, I could just change it to 3 squared. 3 squared is 9. And so now we can use the property when the bases are the same, we set the exponents equal to each other, and so we get x equals 2. All right, let's move on to some interest problems here. Here we have putting $600 in the bank. It earns this much interest, and it's compounded daily. So right off the bat, daily is going to mean 365. This is going to be our principal. This is going to be our rate. Remember to change this to a decimal by dividing by 100. All right, so our equation. So here are our two equations that we use the most often. So we use this one when it's compounded a certain number of times a year. And that's what n would be. That would be, in this case, daily. N would be 365. If it was monthly, it would be 12, and so on. Here, we use this formula here when it's compounded continuously. So when you see that word in the problem, you're going to use this formula here. Okay, so let's go ahead and use this formula here and set up our equation. So our ending amount is going to be equal to our principal, which is 600. 1 plus the rate, which in this case is 0.076, over n, which is the number of times compounded in a year, 365. And we have n again. And we want to know the time. We're not looking for the time. We're just going to put t in there for time. And there's our equation. It says how much money will we have after 3 years? So we're going to use this equation right here, and we're going to plug 3 in for t, and then solve that for a in your calculator. When will you have $1,200? So 1,200 is our ending amount. In this case, we're going to substitute that in for a, and then solve the equation for t. Let's take a look at that real quick. So again, the question is when will we have $1,200? So we want to double our money basically here. So we're going to go ahead and start by undoing this multiplication by dividing. And in your calculator, you're going to want to calculate what this comes out to be. So let's take a look really quick. So plugging this into our calculator, we get 1.00021. Okay, so here's where we are. So remember, when you're solving for a variable in the exponent, we want to log both sides. So I logged the 2 and I logged this side here. Now we can use the power property to move the exponent down front. T log. Now when we solve for t, we're going to start off here by logging, dividing both sides by the log of 1.00021. And then we'll divide by 365. So let's go ahead and go to our calculator and see what that comes out to be. Okay, so here I took the log of 2 and I divided it by the log of 1.00021, and we got 3,301.05. Then I took that number and I divided that by 365, and we got 9.04397. And so we're going to round this to 9 years. So how long is it going to take for us to double our money? It's going to take 9 years. All right, let's move on to, where's my paper? Finding the inverse. So remember, to find the inverse, we have to switch x and the y. So switching the x and the y, And then secondly, we want to do, after we've done that, is we want to solve for y. So solving this for y, we're going to go ahead and divide both sides by 2. And then we're going to rewrite it. So of course our exponent is up here, so we're going to log both sides. Bring that exponent down front. It's a group, so I'm going to go ahead and put grouping symbols on it. Okay. Now we want to divide by log 4 on both sides. So I'm going to go over here. I'm going to do the change of base. Now remember, with the change of base, this is going to be the argument, and this is going to be the base. So we're going to make this into 1 log. 4 is going to be the base, 4 is going to be the base, and x over 2 is going to be the argument. And then we're going to add 1 on both sides, and that's going to be our inverse function. All right, let's look at another example. Switch the x and the y. Now we're going to solve for y. All right, so since our base is e, we're going to do the natural log on both sides. So we're going to have ln equals, bring the y down front using the power property. Now recall that the ln of e is equal to 1. You may have forgotten that, but let me remind you. And so this is going to be 1. So this is going to be our inverse equation. Don't forget the inverse notation on the y. Okay, last thing we're going to cover is composition, proving inverses using composition. So we've been doing this throughout the year, where we have to input one function into the other, and if the outcome is x, when you simplify it, then we have inverses. So let's go ahead and start by, let's just go ahead and put f of x into g of x and see what we come up with. So right here, we're going to plug this in here. So that is now x. So this got substituted in for x, and that's how we got this into that equation. Okay, now we're going to do the simplifying. So minus 2 plus 2, that cancels out. And now we have okay, and so now we can move this using the power property. We can move that to the front. And so 3 to what power gives us 3, which is 1. So this is going to be 1. Let me remind you of that. 3 to what power gives us 3? That's going to be 1. So we're going to have x minus 4 times 1 plus 4. And then minus 4 plus 4 cancel out, leaving us with x. Now, if any of you need me to do another video on composition, verifying composition, just let me know and I'd be happy to post another video on proving inverses using composition. Thanks, guys.